Hi, welcome back. In the previous video, we had two vectors in two dimensions. We had something like this. It's like you're having um, an xy coordinate, sorry, an xy coordinate, something like this. Okay, x and y, and we're having two vector in it. And a vector going this way and that way, or maybe going this way, something like that. Okay, and we having this two vector, we're having an angle in between, or this vector here having an angle between. Okay, now we're gonna have a three-dimensional in the space, vector, two vector in three-dimensional. It means that we're gonna have something like this, like that, and that. Okay, in a three-dimensional vector, I mean two vectors with three dimensions, we'll be having something like that with an x, coordinate, and y and a z. So we have, assuming that we have an I going here, okay, j there, and k right here. Okay, and we'll be having three values. It means like the vector could be like 2i plus 1 plus k plus j minus k, and this is three dimension. Before we had 2i, for example, plus j or minus j, that was two dimension. Okay, so this is what we're gonna have now. Let us now take an example, right? We have in here a vector a with, the value 2i, and before doing that, this is like we're gonna be doing like a effect like this vector right here, okay, 2i. So it means that 2i, 1 2, for example, here, plus j, and j is going this direction, it means it's going this way, and minus k is going the direction, it means that it's going down like this. So, and our vector will be this one here, okay, from 0. It's a position vector, they had this fixed position at 0. So we want to define the angle between all these vectors. It means that the angle will be from here to there, okay, because we're having I mean yeah, this is the angle. That's what the angle between three vectors. We're having one vector, the second one, and the third one. We want to find the angle all between all those three vectors, and that's what we're going to do now. So we're having 2i minus 3j and plus 5k, and the vector b will be um, I minus 3j plus k. Okay, so as we seen before, what we need, our general formula is like the standard AB, the product, the dot product equals to the scalar product, the magnitude of A and B. This is the whole thing is called a scalar product, excuse me. The magnitude, we need the dot product, the scalar product in dot also, and the cosine of the angle between all these point of the vector. So a times b, we can do that here. A times b would be, a dot b would be, we're having 2 times 1 plus minus 3 times minus 3, and with these two value, and the g value, plus 5 times 1. Okay, this is here 2 plus 9, 11 plus 5 and 16. This is equal 16. A times b equals 16. And now we need the magnitude of both vector. So the magnitude of a in this case will be the square root of 2 to the 2 plus minus 3 to the power 2 plus 5 to the power of 2. Okay, and this is going to give us here, we have 4 plus 9 will be 13 plus 25. 25, 13. This is 8. This is 38. Okay, so we have here the square root of 38. All right, so this one here there. Okay, and the magnitude of b, will be equal to, we're having 1 to the power 2 minus 3 to plus minus 3 to the power 2 and plus 1 to the power 2. It doesn't make sense. Okay, right. So this is equal to, we have 9 here plus 2, that will be the square root of 11. Okay, therefore we can write that, we can say that, according to this formula here, we can divide by, on both sides by the magnitude of A times the magnitude of B. On both sides, doing the same thing here, divided by the magnitude of A times the magnitude of B. Okay, then this is going to give us, therefore, this is what I'm writing here, the cosine of theta will be equal to A times B over the magnitude of A times the magnitude of B. Okay, and this is equal to what we got here, 16 over the square root of 38 times the square root of 11. This is equal to um, this is equal to 0.7825. Okay, which means that the cosine of theta equals 0.7825, and therefore theta will be the cosine, the arc sine, arc cosine, or cosine minus 1, the cosine minus 1 of this value right here, 7825. Okay, and this value actually is, the angle is in degree, will be 38.5 degrees. Okay, and this is our angle between, this is the angle we have between these two vectors having a three-dimensional, three-dimension in the space. Okay, so thank you for watching, guys. Again, in the next video we're going to be doing like 3 vectors, okay, or more exercise, more examples about 2 vectors with 2 dimensions and 2 vectors with 3 dimensions. We can also do 3 vectors, but this is coming in the next videos. Okay, so thank you so much. Bye bye.